Hello, math humans. We're going to do 10.6 today. We're going to do a very brief look at parametric equations. So our objectives are that we're going to evaluate sketch curves, and the curves are going to be parametric equations, and then we're going to eliminate parameters. So if we talk about rectangular equations, they're going to be in terms of two variables, like maybe y is equal to x squared. So I have two variables, y and x. My Cartesian coordinate system also is in terms of x and y. A parametric equation, on the other hand, is kind of cool. It adds a new dimension. Okay, we're not talking sci-fi movies, but we're going to add the dimension of time. Okay, and so our equations are going to become require two sets of equations. So maybe an equation looks like this. It has an x component and a y component, 16t squared plus 24 radical 2t. So that would be an example. Parametric equations take two equations because I have three variables, 1, 2, and then the third equation is t for time. Alrighty. If I have three equations, that means that when I do a t-chart, like if I'm going to graph, my t-chart is going to have three elements. I'm going to have time, x and y. X and y are going to be the only two things that show up on the graph. It's still going to look like a regular Cartesian coordinate system. Our time is going to show up by giving a direction on the graph. So let's just do a little example, okay? And it's really not an example, but we want to sketch the parametric. You're going to need your calculator because I'm going to show you many things about your calculator. We're going to be given a parametric equation of t squared minus 4 and y is equal to t over 2. Remember, it takes two equations, to write one parametric equation. For my time interval, which is also something that we have to include, I'm going to go from a negative 2 to 3. And I know it seems a little bit weird to have negative time, but don't get too wrapped up in that detail. So I'm going to make a t-chart that has time, and then I'm going to have x, and then I'm going to have y. So sometimes in the assignments, they're going to ask you to fill the t-chart out by hand. So if I go from negative 2 to 3, I would do a negative 2, and then I'm going to do a negative 1, and then a 0, and then I'm going to enter a 1, a 2, and a 3. Okay? Well, if time is a negative 2, that means x is going to be 0, and I'm just going to fill in these values for you instead of walking you through the calculation. Y is going to be calculated separately, so it's going to be a negative 1, a negative 1/2, 0, a positive 1/2, 1, and 3/2. So if I'm graphing a parametric by hand, okay, so here's going to be my coordinate system with an x and a y, and I'm going to start with my first value. So when time is a negative 2, so I'm going to graph 0, negative 1. So here's a negative 1, and I'm going to put a dot there. My next one is at 1, 2, 3, so a negative 3, negative 1/2. The way that it's going to look when I graph by hand is I'm going to show an arrow to show the progression of time. Okay, and then if I graphed my next one, it's going to be, here's a negative 4, and it's 0. Okay, so I'm going to go to here. So in between each data point, you're going to have an arrow showing the progression of time. And then my next one is a negative 3, positive 1/2. We'll put 1/2 right there. I'm going to have a curve to get to there. And then I have 0, 1. So I'm going to go to this point. And then my next one is going to be at 1, 2, 3, 4, 5. And then 3/2. So this is 1.5, 3/2. There's going to be my data point. And then there's my arrow. And so that would be the way your graph looks for a parametric if you do it by hand. So what we're going to do now is clear what's on my calculator. The first thing that I'm going to do, and if you'll notice on my calculator, I have mine in parametric mode. Okay, parametric means I'm adding that third variable. So I'm going to put this equation that we're doing right now into my calculator. When I go to my y equals, notice, let me get my cursor out of the way, notice that it takes 2 lines to be able to put in one parametric equation. So I entered our parametrics. The next thing that's kind of interesting to do, so if you go to your calculator and go to the left of the equals, or the left of your variable, and hit enter, and then you can just change to different types of lines. This one is what I call the bouncy ball, and you'll understand shortly. The next thing that I'm going to do is show you the window. And so if I can move my cursor out of the way, okay, these window requirements on this particular curve are what you need to have. Notice that my t-step, which means my change in time, is going to be 0.1. My change in x and change in y is going to have the same step or same scale. The next thing that I'm going to do before I show you the graph is show you that I can actually go look at the table, and I can tell my table to start at a -2, and then I can go look at my table. And I can always enter my 2 equations and generate the table without having to do it by hand. Okay, it depends on the way the problem is written. So now I'm going to enter my graph, and so watch because it's kind of entertaining. Okay, so as it graphs, notice the bouncy ball is moving. Notice we got the same basic graph, and it shows the progression of time as it marches along through the problem. So that's kind of entertaining. In PreCalc, we're really only getting a very polite exposure to to parametrics. We're really not going to do a lot with it. You won't do a lot with it again until either physics or Calc 2. So the next thing that we want to talk about is eliminating the parameter. Okay, and this is going to be a type of problem that you see often. So I want to convert the parametric equation to a regular rectangular equation. Alrighty, so basically what we're going to do is we're going to solve for t, and I'm going to put it in quotes, an easy equation, and then I'm going to substitute into the second equation. It doesn't matter which equation you choose to use to solve for t. I would pick the easy one, and then you're going to just do some substitution. So for our second example, the directions are going to say eliminate the parameter. So the equations that we're going to be given is the one that we were just doing, t squared minus 4, and y is going to equal t divided by 2. So this one is actually a little bit easier because I don't have to deal with the plus or minus. So I'm going to solve for t. So t is equal to 2y. Now I'm going to take this and substitute it into my x equation. So x is going to equal 2y squared minus 4. And then I need to solve for y. So I'm going to take the 4 to the other side. So 4y squared is equal to x plus 4. Y squared is going to be 1/4 x plus 1. I divided both sides by 4. Okay. And actually, let's not do that because I think the math is going to be more polite if I leave it here. So then I'm going to write this as y squared is equal to x plus 4 over 4. You'll see why when we take the square root. So now I take the square root of both sides, and I'm going to get y is equal to plus or minus. When I have a fraction under a radical, this is the square root of x plus 4 over the square root of 4, which is 2. So I'm going to get y is equal to plus or minus 1/2 times x plus 4. And then that would be my new equation without the parameter. Okay, so now let's go the opposite direction. Now let's generate So example number 2, let's generate a set of parametric equations. So we're going to find a set of parametric equations, and we're going to be given that y is equal to 1 minus x squared, and then we're going to be given t is equal to 1 minus x. So in these types of problems, my pen just had an explosion. In these types of problems, they have to tell you what your parameter is going to be, otherwise you can't just generate it. So now what I'm going to do is I'm going to solve for x. So I get t minus 1 is equal to a negative x, and x is going to equal 1 minus t. Well, now I can take this and substitute it in here. So I'm going to get y equals 1 minus t quantity squared. I'm going to simplify this. You could leave it like this, but I'm going to simplify it. So this is 1 minus, square the first term, multiply those two guys together and double it, plus t squared. So this is going to equal 1 minus 1 plus 2t minus t squared. So it's going to be a negative. Those guys cancel, t squared plus 2t. This is y. And then I'm going to write my x is equal to 1 minus t. And this is my set of parametric equations. All right, let's do one more of these, eliminate the parameters. Actually, I lied, 2 more. So we want to eliminate the parameter. This time we're going to be given x is equal to 1 over the square root of t plus 1. And then the other one is y is equal to t over t plus 1. And notice that t has to be greater than a negative 1. Otherwise, the world is going to explode right here. So neither of these equations is super simple. This one's actually a little bit less work. So I'm going to try to solve for t. So that means that I'm going to square both sides of the equation. So I get x squared is equal to 1 over t plus 1. I'm going to cross multiply, and I'm going to get t plus 1 times x squared equals 1. I'm not going to distribute, so t plus 1 is equal to 1 over x squared. T is equal to 1 over x squared minus 1, okay? So there's my time. Now I'm going to take this, and I'm going to substitute it into this equation. But because I have a fraction over a fraction, I'm actually going to rewrite my time as 1 over x squared minus x squared over x squared. And I'm going to get 1 minus x squared over x squared. This will be easier to substitute into here. So now when I do my y, I'm going to get time, which is 1 minus x squared over x squared over, and then I have 1 minus x squared over x squared plus 1. I'm going to need to put the denominator together, so I'm going to multiply this guy by x squared over x squared. And so then, let me go to another page. In the numerator, I'm going to have 1 minus x squared over x squared. In the denominator, 1 minus x squared plus x squared over x squared. The x squareds cancel. So now I have 1 minus x squared over x squared times x squared over 1. And all I did is multiply by the reciprocal. The x squareds cancel, and so I get 1 minus x squared. So that was a lot of work to get that my equation without a t, with no parameter, is going to be y is equal to 1 minus x squared. Alrighty, I have one more example because it's kind of entertaining. So I want to eliminate the parameter. And this time our parameter is a little bit different. So I'm going to have x is equal to 3 cosine theta and y is equal to 4 sine theta. and I'm going to go from 0 less than or equal to theta less than or equal to 2 pi, so in one full rotation. So notice that my third variable in this case is theta. So it's not time. We can always have time, but this is another type of parameter where I have theta. Alrighty, so I'm going to solve for theta. So the cosine of theta is going to equal x over 3, and I'm going to have the sine of theta is going to equal y over 4. Because we are working with sine and cosine, it's a cool little trick. I'm going to use the Pythagorean identity, and remember that the Pythagorean identity says that the cosine squared theta plus sine squared theta is 1. So I'm going to do that. So I'm going to square both situations. So I'm going to have x over 3 quantity squared plus y over 4. Did I write it down wrong? Nope. Quantity squared is equal to 1. And technically you could stop here, but this is x squared over 9 plus y squared over 16 is equal to 1, and this is a vertical ellipse. So if you wanted to be really tricky, you could put these two equations in your grapher. You could change your window, and then you would actually get a really nice looking vertical ellipse. So that's kind of cool. Alrighty, my dears, that is it for today. I will see you soon.